morning, everyone. Myself, Dr.K.ANANDA KUMAR, lecturer in economics, PV Giri Government Degree College, Dumpagadapa. Today, I am going to discuss about normal distribution, constants, and properties. Let us see about the learning objectives of the topic. To know about normal distribution. Second one, to study about the constants of the normal distribution. Third one, to discuss about properties of normal distribution. The normal distribution is a continuous distribution of data that has the shape of a symmetrical bell curve. This distribution was developed by Dr. de Moivre in 1733. This distribution was rediscovered by the German mathematician Gauss in 1809 and again by the French mathematician Pascal in 1812. It's also known as the bell curve, normal frequency distribution, normal probability curve, normal curve of error, Gauss curve. It is also called the Gaussian distribution after Carl F. Gauss, who created mathematical formula for the curve. Normal distribution is also called Gaussian distribution or Gaussian law of error, as this theory describes the accidental error of measurements. Example. Height is one simple example of something that follows a normal distribution pattern. Most people are of average height. The number of people that are taller and shorter than average are fairly equal, and a very small number of people are either extremely tall or extremely short. For example, heights and weights of men and women have this distribution. Standardized test scores are normally distributed. Sometimes lifespans of manufactured parts of equipment form a normal distribution. Features of normal distribution. Normal distributions are symmetric around their mean. Second one, the mean, median, and mode of a normal distribution are equal. The area under the normal curve is equal to 1.0. Normal distributions are denser in the center and less dense in the tails. Normal distributions are defined by two parameters, the mean mu and the standard deviation, that is sigma. 68% of the area of a normal distribution is within one standard deviation of the mean. Approximately 95% of the area of a normal distribution in two standard deviations of the mean. Let us see about constants of normal distribution. Since the mean, mode, and median are the same in a normal distribution, there is no need to calculate them separately. These values represent the distribution's highest point or the peak. All other values in the distribution then fall symmetrically around the mean. The width of the mean is defined by the standard deviation. In fact, only two parameters are required to describe a normal distribution, the mean and the standard deviation. The first one, the mean. The mean is the central highest value of the bell curve. All other values in the distribution either cluster around it or at some distance away from it. Changing the mean on a graph will entire curve along the x-axis either toward the left or towards the right. However, it symmetrically will be maintained. Second one, the standard deviation. In general, standard deviation is a measure of variability in a distribution. In a bell curve, it defines the width of the distribution and shows how far away from the mean the other values fall. In addition, it represents the typical distance between the average and the observations. Changing the standard deviation will change the distribution of value around the mean. A smaller deviation will reduce the spread, tightening the distribution, while a larger deviation will increase the spread and produce a wider distribution. All the distribution gets wider. It becomes more likely that values will be farther away from the mean, skewness and curtices in a normal distribution. Skewness represents a distribution's degree of symmetry. Since the normal distribution is a perfectly symmetric, it has a skewness of 0. In other distribution with the skewness less than or greater than 0, the left skewness, left tail, left in or the right tail will be longer respectively. The mean of the normal distribution is x. The standard deviation of the normal distribution is OH2 minus 02. The mu 3 minus 0. And the mu 4 is equal to 304. By our moment coefficient of skewness, B1 is equal to 0. Mu sigma B2 or moment of coefficient of curtices B2. H4 304 mu sigma 04 is equal to 3. For a normal distribution, the value of B2 shall be 3. If the value of B2 is more than 3, the curve is leptokurtic. And if the value of B2 is less than 3, the curve is called platykurtic. Now let us see about the properties of the normal distribution. The range of normal distribution is from negative infinity to positive infinity. It means normal curve will never touch x-axis. Second one, normal distribution is without any type of skewness. Third one, the normal curve is asymptotic to the baseline, that is, it never touches the baseline on both sides of the curve, though the curve remains close to the baseline on either sides. The normal distribution or curve has a bell shape and is symmetrical. Mean median is equal to mode. The other property, this is because the shape of the data is symmetrical with one peak. Symbol mu represents a population mean and x bar represents a sample mean. There is one maximum point of normal curve which occur at mean. As it has only one maximum curve, so it is a unimodal, that is, it has only one mode. In binomial and Poisson distribution, the variable is discrete, while in this it is continuous. The total area of normal curve is the area to the left and the area to the right of the curve is 0.5. No portion of curve lies below x-axis, so probability can never be negative. The curve becomes parallel to x-axis, which is supposed to meet in at infinity. Here mean deviation is 4 by 4 standard deviation. The upper and lower quartiles remain at equidistance. Quartile deviation is equal to 2 by 3 standard deviation. Quartile deviation is equal to 5 by 6 mean deviation. Quartile deviation is to mean deviation is to standard deviation is equal to 10 is to 12 is to 15. 4 standard deviation is equal to 5 mean deviation, that is equal to 6 quartile deviation. Now let us see about the importance of normal distribution. In case the sample size is large, the normal distribution serves as good approximation. Due to its mathematical properties, it is more popular and easy to calculate. It is used in statistical quality control in setting up of control limits. The whole theory of sample test T, F, and chi-square test is based on the normal distribution. Normal equation. The normal equation, the value of the random variable y is equal to 1 by sigma sqrt 2 pi is equal to e minus x minus mu 2 by 202, where x is a normal random variable, mu is the mean, sigma is the standard deviation, pi is approximately 3.14159, and E is approximately 2.71828. The random variable x in the normal equations called the normal random variable. The normal equation is the probability of destiny for normal distribution. Now let us see about normal curve. The graph of the normal distribution depends on two factors, the mean and the standard deviation. The mean of the distribution determines the location of the center of the graph. The standard deviation determines the height and width of the graph. All normal distributions look like a symmetric, bell-shaped curve. When the standard deviation is small, the curve is tall and narrow. When the standard deviation is big, the curve is short and wide. Standard normal distribution. The standardized value of normally distributed random variable is called a z-score and is calculated using the following formula. That is equal to z is equal to x minus mu by sigma. X is equal to the value that is being standardized. M is equal to the mean of the distribution of distribution. S is equal to standard deviation of the distribution. As the formula shows, a random variable is standardized by subtracting the mean of the being standardized and then dividing the difference by the standard deviation of the distribution. Once standardized, a normally distributed random variable has a mean of 0 and a standard deviation of 1. As you can see from the notation to the right of the curve, mz is equal to 0 and sz is equal to 1. To see how a random variable is standardized, imagine you have a random variable x that is normally distributed with a mean of 20 and a standard deviation of 10. What would be the standardized value z-score of 40? To solve this problem, you would use the z-score formula. Using the information from the example, you know that x is equal to 40, m is equal to 20, s is equal to 10. Substitute these numbers into the formula and solve. In this example, the standardized value of 40 is 2. These z-scores are important because they tell you how far a value is from the mean. When you standardize a random variable, its mean becomes 0 and its standard deviation becomes 1. Therefore, if the z-score of x is 0, then the value of x is equal to the mean. If the z-score of x is 1, then the value of x is 1 standard 1. Standard deviation above the mean. If the z-score is minus 1, then the value of x is 1 standard deviation below the mean. If the z-score of x is 2, then the value of x is 2 standard deviation above the mean. If the z-score is 2 is minus 2, then the value of x is 2 standard deviation below the mean. In the earlier example, the z-score of 40 was 2. This tells you that 40 is 2 standard deviations above the mean. If the Z score is 2, then the value of a 2 standard deviations below the mean. This tells you that 40 is 2 standard deviation above the mean. Thank you.